in this lesson we're going to be talking about surface area and volume of cylinders. And so you'll probably find some similarities between when we're talking about cylinders and when we're talking about prisms. So a prism is a polyhedra, while a cylinder can't be because it has that circular base. So a cylinder is a solid with congruent circular bases that lie in parallel planes. So the two circles have to be parallel. The altitude is the perpendicular distance between those bases. So we're mainly looking at right cylinders where those segments joining the centers of the bases are perpendicular to both. The lateral area of the cylinder is going to be the area of the curved surface, which is going to be equal to the product of the circumference and the height. So if you peel that lateral part off of the circles, it would be the perimeter times the height, or the circumference instead of the perimeter, because we're not talking about a polygon. So it's the circumference times the height. So the surface area is going to be the sum of that lateral area and the area of the two bases. So if we look at the surface area of a right cylinder, we have 2 times the area of the base. And since those are circles, we have the formula for the area of a circle, which is pi r squared. And that's going to be added on to the circumference, which for a circle is 2 pi r if we know the radius, and then times the height of the cylinder. So when we're looking, we have 2 times the base plus circumference times height, and if we plug those formulas in, that's 2 pi r squared plus 2 pi r h. So the volume formula for a cylinder is going to be the area of the base times the height, and so the area of the base with that circle is going to be pi r squared times the height. All right, so if we look at these formulas, they might seem a little bit familiar because we already looked at prisms, and now we're looking at cylinders. So let's compare these things. I still have our prism notes pulled up. So if I'm looking at surface area first, and if I look at my cylinder, my surface area formula is 2 times the base plus the circumference times the height. So now let's go back and let's look at what the surface area formula was for a prism. So if I go back to the prism, the surface area of a prism was 2 times the base plus the perimeter times the height. So surface area equals 2 times the base plus the perimeter times the height. So these look pretty similar. The only difference is that the cylinder uses circumference and the prism uses the perimeter. So remember that the circumference is what goes around a circle and the perimeter is what goes around a polygon. So the only thing that changed is that we're using circumference instead of perimeter for surface area. Now let's look at our volume formulas. So if we're looking at our volume formulas for a cylinder, we have that volume is base times height, and then we can narrow that down a little bit because since the base is a circle, that's going to be pi r squared times the height. All right, so now let's go back and look at the volume of a prism. So the volume of a prism looks a lot alike. So our volume equals base times height. It's just that our base is not a circle here. So we had rectangles as bases, we had triangles as bases. We can use a hexagon or a pentagon as a base, but notice that the main part of this formula stays the same. So cylinders and prisms are a lot alike when it comes to their formulas. So let's jump right in and start finding surface area and volume. So in this first cylinder, the height of the cylinder is going to be 4 centimeters and the radius is going to be 6 centimeters. So I know that the base is the circle. So what I like to do a lot is I like to do my pre-work because the base shows up in both formulas. So if I'm going to find the area of the base, that's going to be a circle, so it's pi r squared. So I'm going to plug in my radius. So that is pi times the radius, 6 squared. So there's two different ways that I can write this because I can have the exact answer, and sometimes my answers are asked for in terms of pi, or I can estimate it with a calculator. So let's pull up our calculator and also estimate it. So if I'm going to estimate that, I'm going to do 36 pi, and just to check my directions, round to 2 decimal places. All right, so 36 pi, when I round it, that's going to give me 113. And then in the thousandths place, because we're rounding to the hundredths place, is a 7, which means that that 9 is going to have to round up, which makes this 113.10. All right, so I have the area of my base now. The next thing that shows up in my formula for surface area is the circumference. So the circumference is 2 pi times the radius. So if I plug this in, 2 pi times 6 is going to give me 12 pi as my exact answers if something's asked for in terms of pi, or I can estimate that by typing it in with the pi button, and that gives me 37 point, and then again I have a 9 that's going to round up, so this would be 37.70 as my circumference. So I have my base and I have my circumference when my formulas need them. So one big question is, when should you use these things? And the answer to that is always going to be in the directions. So notice up here that my directions told me to round, which tells me that I'm going to be plugging in something for the pi. And notice that it doesn't say to use 3.14. So if you do not see in the directions to use 3.14, then always use the pi button. So unless it tells you specifically to use something, then use the pi button. All right, so going back to this one, now we need to find our surface area and our volume. So for our surface area formula, remember it was very similar to the prism. It was 2 times the base plus, instead of perimeter, we're going to use our circumference times our height. All right, so let's plug in these numbers that we've already found. So this will be 2 times 113.10. And then I'm going to add on the circumference times the height. So that'll be the circumference of 37.70 times the height, which was 4. All right, so let's go on and multiply these things together. So I'm just going to type it in as one big long string, which means that I need to be super careful when I'm typing. So that's 2 times 113.10, close them, plus 37.70 times 4. All right, so whenever I plug that in, I get a answer of 377. So after multiplying, my decimals worked out and it came out as a whole number. So the surface area here, and remember that area is measured in square units. So since these are measured in centimeters, this will be square centimeters. So the surface area is 377 square centimeters. So we talked about nets in our prisms, but we haven't talked about it in a cylinder. So why do we use this formula? So remember that whenever you're creating a net, you're kind of taking your three-dimensional shape and taking its pieces apart and laying it out flat. So for a prism, or for a cylinder, we have the two circular bases, and then there's this part that wraps around it. So what we're doing is we're unwrapping this circle here. So we're taking it around the edges and like peeling it back. So whenever I do that, it kind of lays out flat and it creates a big rectangle. So the height is still the distance between them, But what I've done is I've unwrapped it so that this side length is the circumference. So I have the area of the two circles plus circumference times height to make up for this rectangle. So that's how I'm getting my surface area. It's like unwrapping that into a two-dimensional figure and laying it out flat. So now let's figure out how much can fit into the cylinder, and that means like filling the three-dimensional space. So that's where we use our volume formula. So to figure out how much could fill this, we're going to use the area of the base times the height. So I already found the area of the base up here. So I'm going to do 113.10, and I'm going to multiply that by the height of the cylinder, which was 4. So let's go to our calculator, 113.10 times 4, and that gives me a volume of 452.4. Now volume is three-dimensional space, so we use cubic units. So this will be centimeters cubed or cubic centimeters. So that's how much space there is to be filled. So if we wanted to, if this was like a glass and we wanted to fill it up with water. All right, so let's look at our next cylinder. So here we have a height of 8 inches and a radius of 5. So I always like to do my pre-work and go on and find the volume and the circumference before I get started. Or not the volume, the area of the base. So the area of the base, since it's a circle, is pi r squared. So whenever I plug in the 5 for the radius, that'll be pi times 5 squared. So again, there's two ways I can write it. I can get the exact answer by leaving it in terms of pi. So 5 squared is 25. So the exact area would be 25 pi. Or I can estimate it on a calculator. It did not tell me to use 3.14, so I'm going to use the pi button. So 25 pi, and then it says round to 2 decimal places. So let's go in and do that here. So 78.54 is the area of the base that I'm going to use. The other thing I need in my formula is my circumference. So the circumference of this base is going to be 2 pi times the radius. So if I plug in the 5, that'll be 2 pi times 5. So in exact terms, in terms of pi, that would be 10 pi. Or I can estimate it using the pi button. So 10 pi is 31.42 when I round. So 31.42. So now that I have that work done, I'm ready to use my formula. So for the surface area, I take the two circular bases, 2b, and I add that to the circumference times the height, because remember that creates that rectangle. All right, so I do 2 times the base, and whenever I plugged that in and rounded it, I had 78.54. And then to that, I'm going to add the circumference, which was 31.42, times the height, which is 8. So I'm going to carefully type this into my calculator. So 2 times 78.54 plus 31.42 times 8, and I get 408.44. Area is in square units, so this is square inches. I also need to find the volume. So the volume of a cylinder is the area of the base times the height. So whenever I plug this in, the area of the base was 78.54. I'm going to multiply that by the height, which was 8. So in my calculator, 78.54 times 8 is 628.32. All right, so volume is three-dimensional space, so it's in cubic inches. So for our last two examples, we're going to be given either the surface area or the volume. So in the first one, we're given the surface area, and in the second one, we're given the volume. So we're going to find the value of the variable. So I have surface area is 967.12. I have the radius, but I need to find the height. So the surface area formula is 2 times the base plus the circumference times the height. So let's go in and do our pre-work because I have the radius. So the area of the base is going to be pi times the radius squared. So in exact, that's going to be 49 pi. When I estimate it, I get 153.94 when I round it to 2 decimal places. Oops, this one says round to 1 decimal place. So 153.9 for the base. For the circumference, I do 2 pi times the radius. So this is 2 pi times 7. So in exact, that would be 14 pi. And estimated, that will be, whenever I round to the nearest tenth, the first decimal place, that will round to 44.0. So now I'm ready to plug in what I know. So I know that the surface area is 967.12. I already found a value for the area of the base, which was 153.9. And I found the circumference was 44. Now the height is what I don't know. That's where the x goes. So now let's simplify this first. So 2 times 153.9 gives me 307.8. So now that I have my equation all simplified, I'm ready to start solving and moving stuff across that equal sign. So I'm going to subtract 307.8 from both sides. So 967.12 minus 307.8 gives me 659.32. Right, and I'm going to bring down that 44x. All right. So now to get the x by itself, I need to divide both sides by 44. So I'm going to take 659.32 and divide that by 44. And I want to round to the nearest tenth, the first decimal place. So when I do that, I get that x equals 15 or 15.0. So I found the value of the variable. So now let's look at our next one. So here we're given the volume. So x is my radius and 10 is my height. So this one, whenever I think about my area of the base and my circumference, my variable is going to be in there. So for this one, since I'm finding the volume, it's given me the volume. For the volume formula, I only need the base, the area of the base. So the area of the base is pi r squared. But all I'm doing is I'm replacing that r with an x because I was given the variable there. So when I plug that into my formula, I'm going to have pi times x squared times the height of 10. So I'm also going to plug in the volume on the other side of the equation, which was 283. So I kind of got a problem here because my variable's under that exponent. So I just need to peel these pieces away from the outside in. So the first thing I'm going to do is I'm going to get rid of this times 10 by dividing by 10. So the opposite of multiplying by 10 is to divide by 10. So I'm going to divide both sides of the equation by 10. That's going to give me 28.3. So 283 divided by 10 is 28.3. And now all I'm left with is this stuff in the parentheses. So pi times x squared. So pi is still a number. So I'm going to go in and divide both sides by pi next. So I have 28.3. And since it didn't tell me anything else, I'm going to divide it by the pi button. And if I go to 1 decimal place, this would be 9.0. So now I've gotten it down to where it's just that x squared. So the opposite of squaring something is to take the square root. So I'm going to take the square root of both sides. And that's going to leave me with just x on the right side. And then I need to do the square root of 9.0, which is 3. So the value of the variable x is 3. So we can use those formulas and we can use pieces of information if we're missing a part, if we're missing the radius or the height.